Good morning, guys. Thanks for coming for today's session. I know it's early in the morning, especially if you're coming from the West Coast. This is only 6 a.m. in the morning. By way of introduction, my name is Sean Lee. I'm a program manager of Azure Database for MySQL. And today's topic is to develop and deploy web apps using Azure Database for MySQL and Postgres. Let's take a look at what I have in store for you guys today. So in today's session, we're going to be doing a lot of demos. First, we're going to create a few web apps in Azure Database using both Azure Database for MySQL as well as Postgres. And then I'm going to jump into a migration scenario and migrate an existing shopping cart app from my on-prem to Azure. And lastly, we're going to talk about some Azure Database fundamentals. Because we're database guys, and this is what we do. But before we jump into any of these main topics, I figured I'd like to open up today's session and share a personal story of mine. The story is about Thanksgiving dinner preparation. About 2 years ago, my wife and I moved into our new condo in downtown Seattle, and we decided to throw a housewarming party during Thanksgiving Day. Now, my wife and I are not experienced cooks, so what we did is we went online and we downloaded this recipe that tells you how to prepare a Thanksgiving dinner. Now, along with the recipe was a daunting list of items you need to buy in order to prepare the full Thanksgiving meal. The thing had 5 categories. It was meat, produce, dried herbs, baking ingredients, and other miscellaneous items. With over 60 items on the list, we started our shopping the week before Thanksgiving week. Now, we all know that first impressions are always important, and because this was the first time we had guests over to our new place, we were pulling out all the stops. Our objective was to get the best ingredients, but on a Costco budget. So, needless to say, we weren't able to find everything in one place, and we had to hit up a couple of shops. The whole shopping experience took me about 3 days to do, and it was exhausting. But fast forward to Thanksgiving Day, we woke up early enough in the morning, and I took the turkey out of the fridge, stuffed it with the ingredients I prepared the night before, and everything was coming along beautifully. Until when I was ready to bake the bird. Now let me tell you, nothing could have prepared me for the sheer horror I saw when I opened the oven door. It turns out there was no baking pan inside the oven. So we bought everything except the baking pan. It's really an innocent mistake because this is not the first time we bought our condo, and inside the new oven of our last condo is a spanking new baking pan. So we had assumed that every new oven is going to be equipped with a baking pan, which is not the case here. Since this is Thanksgiving Day, with all the shops closed, our chances of getting a new baking pan from the store was slim to none, and unfortunately, Slim just left. So my wife and I stood there in awe with our jaws dropped to the floor before one of us snapped out of it and started calling our friends for help. Luckily, we were able to get a hold of a dear friend of ours and borrow her baking pan and save the day. So the reason I'm sharing this story with you is because I was reminded of the same exact experience the first time I was setting up my Wordpress web app on a VM. Let's look at what that step looks like. So the first thing you need if you were to set up a WordPress site in a VM is you need a lamp. Now, does anyone know what a lamp is? And here's a hint. It's not this guy here. Anyone? Yes, sir. That's right. You're correct, sir. It's these guys. All right. So it's Linux, Apache, MySQL, and PHP. And depending on your level of familiarity with these open source systems, to set this up, it could take anywhere between hours and days. So now you've got your lamp, and you're ready to set up your WordPress site in a VM. There are 8 more steps involved, okay? 8 more steps involved in this slide if you were to do this on your own. I realize there's a lot of words on this slide. Don't bother reading it. Instead, I will read it to you because I can never remember half the stuff on this list myself. So the first thing you're going to do is you are going to install a MySQL database for the WordPress along with a new user account. Then you're going to create firewall rules on both your MySQL as well as your application server. The third step is to download the WordPress site. And then there's this esoteric concept of secret keys. Why do you need secret keys? I don't know. But once you get your secret keys, you need to update your WordPress config file with your secret keys and database connection file. Now, just think when you're about to done with this process, we're not quite out of the woods yet. We need to copy everything we just done to the web folder. In a Linux system, this is the www/html folder. And you also want to make it secure by changing the folder permissions. Lastly, to wrap things up, we're going to complete the WordPress website via the setup wizard. That sounds exhausting, doesn't it? Now let's switch over and take a look at the process on Azure side. At a high level, we have about 3 steps. Your first step is going to be pick up the WordPress app template from our Azure Marketplace. And this will then in turn get the LAMP. It's going to download the WordPress bits from a repo and then making everything secure for you. And because Azure Database for MySQL and Postgres is deeply integrated with our WordPress in the marketplace, there's no need for you to create an additional user account and hook up your new web app with the MySQL or Postgres database. Everything is just connected by default under the hood. And the third step is as identical as step 9, as what we just saw, which is completing the setup process using the default WordPress setup wizard. So now let's jump into action and see this in a demo. Let me switch to my demo machine here. OK. So what you're seeing here is our Azure portal, or the marketplace. What I'm going to do first is I'm going to create a brand new WordPress site from scratch. And I'll do that by click on the plus sign here and pick my WordPress template. Now, there are multiple ways you can do this, but I find the easiest way to pick the template is just to type the word WordPress in the search bar. And the search is going to return me a whole bunch of WordPress template. For this demo, I'm just going to pick the plain vanilla version of WordPress. Click on Create. And in this wizard, the first thing we need to tell the WordPress setup wizard is the application name. So since this is a shared account, I like to prefix the application name with my login name, and I'll just give it a name called WordPress 2. WordPress 2 is already taken. The wizard is smart enough to detect if this is a valid name. OK, WordPress 3. The subscription is a Azure-wide concept. It's the same subscription that you would use for anything you have on the Azure Marketplace. Now, let's take a look at our database provider here. You have a few options here. The first option is you can use what's called a in-app database provider. What that is, it's a standalone MySQL or Azure database that sits in the same hardware as your web app. So what that means is it's using the same resources that is allocated to your web app. And it's probably the easiest way to set up a web app because due to the number of steps that are involved here. But the downside here is if you went with the in-app approach, it's not really scalable. Once you pick your in-app database here, you have no ability to scale up or down. The second option is to pick an existing Azure database for MySQL or Postgres. And that is, in fact, what I'm going to do here. And the third option is obviously, let's create a new, a new database on Azure. So to use my existing database, what I need to do is use your web app needs to reside in the same resource group as your database. Now let me go ahead and explain the concept of resource group. I like to think this as a plastic box. This is where you throw all your resources in logical grouping. So if you have a web app, then you have your web app application, you have your database resources, maybe you have a static IP address that will, and the way you can logically organize them together is you can put them all in one resource group, and so later on if you want to delete it, you can go to your resource group, select everything, and delete it. So the resource group here that I'm going to use for my existing database is called CODemoDB. And this is going to be an Azure database for MySQL. Clicking on the Database tab. Again, under this resource group, I'm presented with the option of creating a new database server, but I don't want to create a new database server, so I'm just going to use an existing database server. I only have one server. It's called CODemoDB, but let me enter my password here. And however, I would like to create a new database within my existing database server. So, and by default, that is the case. WordPress is going to assign a random name, and I'm OK with that. So let's click on OK. And then I'm going to ping this guy to my dashboard once it's created. Once you create click on the Create button, it's going to perform a bunch of validations, and you can see the deployment is already in progress. Depending on the hardware setup that you have chosen for your WordPress web app, as well as the database instance, this provisioning time could vary anywhere between 2 minutes to over 6 minutes. So what I've done here for this demo, in the interest of time, is I've already pre-provisioned a WordPress website to show you what it would look like once the provisioning is over. So let me go into my the web app here. Under Overview, there is a URL that is generated based on the app name that you've given. So let me click on this guy here, and here you see is the step number 9 or number 3 is the default WordPress setup wizard, where you can just go on. I don't think well, you get the idea. I'm not going to go through the wizard, but the basic idea is you enter information, and then you have your brand new WordPress website. So that's on the MySQL side. What about Postgres? Again, I'm going to do a similar demo for Postgres using a very popular framework called Django. And to do that, again, I'm going to go back to my marketplace. And since I've done this before, I'm just going to pick the template from my recently created list. Okay, I'm going to give it a app name. In this case, it's going to be a Django 2. Okay, Okay, and in this case, I'm going to use the third option, which is create a new Azure database for Postgres instance. So what I'll do is, again, going to the Database tab. By default, the web app is going to populate some server name as well as default admin login here. Since this is demo, I'm going to leave everything as is and just give it a password. Okay, here we go. Now there are two versions of Postgres. We currently support version 9.5 and 9.6. If you click on this pricing tier, here's something I want to show you. If you have created an Azure database for Postgres before, this interface should look similar. So in this interface, you have the ability to pick the SKU of your database. By default, we're defaulting everything to our standard 100 tier. And over here, you do have the ability to scale up or down, all the way to 800. And independently, you can always also scale your storage of the database. You also have the ability to pick a basic instance, but for this demo, I'm going to stick with the standard 100 instance for Postgres. Going to click OK. Again, click OK here, and then ping this guy to dashboard and create. Again, the provisioning time is going to take a few minutes. I'm not going to wait for that. And what I'll do is, let me show you the after effect. Once this is all provisioned, and you click on the URL from the overview pane, this is what the page is going to look like. Okay, so on the Django side, it doesn't have that fancy setup wizard, and it's a lot less articulate, and it just says your Django site is up and running, and now get to work. Okay. So now you've seen how easy it is to set up a WordPress site with MySQL and a Django website using Azure Database for Postgres. In the next segment, we're going to jump back to my demo here. Is it 6? 5? Okay. In the next segment, I'm going to migrate an existing shopping cart application that I have from on-prem to Azure. And there are essentially 4 steps involved here. Your first step is going to create a new web app on Azure. And then step 2, you're going to want to deploy your code to the web app that you just created on Azure. And then on the back end, you're going to want to migrate your database over from your on-prem database to Azure Database. And the last step is just decommissioning your old setup. So again, I'm going to switch back to my demo machine. And for this demo, I've prepared a shopping cart application. This is what it looks like. It's Sean's Bike Shop, and I have a bunch of biking accessories. And this is built on WordPress technologies. And I'm going to go ahead and migrate this over to Azure. So first, again, coming back to my Azure Marketplace. As I mentioned, the first step is going to create a new web app template. Clicking on the plus sign here. And I'm going to choose the web app template. Now, the difference between this web app template and the WordPress template you guys seen before is the web app template does not have any image that's predefined when it's provisioned. And the reason it's appropriate for me to pick the web app template here is because my source code for the shopping cart application you already saw sits on GitHub. So in the second step, I'm going to directly connect this new web app application to GitHub and pull all the code from there. There's no need to start with a default WordPress web app template. So again, I'm going to give this a name. I'm going to call it Bike Shop 3. And Let me do /4. And then I'm going to create a new resource group for that. Now there's one more thing I want to show you on this screen. If you click on this App Service Plan tab, what App Service Plan is, it's a similar concept as resource groups. Think of that as a logical containment of all your web app resources. Now the difference between your web service plan and your resource group is within your single resource group, you can have multiple app service plan. So I'm going to create a new app service plan. And under pricing tier, you have the ability to pick what kind of hardware you would like to provision for your new web app. Now, by default, it is going to give you the S1 or standard tier. But in this demo, I'm going to pick the P3 V2 or the premium tier, which is going to give you 4 cores, 14 gig of RAM, and SSD, and 250 gig of storage. Let me click that OK, and then I need to give the name for this app service plan. Let me call it, well, I can call it the same as my resource group as well. And you also have the option to pick which location you want to set up your virtual machine. So in this case, since we're on the East Coast, I'm going to pick East US 2, clicking OK, and then again, it needs to go through some validation steps, and this wizard is going to go ahead and provision the hardware for me. Deploying web app. Okay, so my deployment just succeeded. Give it a few more seconds here for it to load. Okay. So here's the URL. Notice the URL starts with co-dj2. No, sorry, that is the wrong wrong web app. The COBK4 is the web app that I just created. Now, this is my resource group. Let me go and click on my actual web app. Oh, that's the service plan. Back up. Keep clicking on the wrong links. Okay, here we go. This is the URL, COBK4. And now, if you click on this link, it doesn't have anything on it. It's just a blank page because essentially I've only provisioned the hardware and I don't have any source code behind it. So what I'm going to do now is I'm going to connect this new web app with my GitHub account. And to do that, let's head over to deployment options. Click on choose source and pick GitHub. Now, other than GitHub, you have a slew of other options. You can use Visual Studio Team Service, Bitbucket, Dropbox, or you can even use OneDrive for that. But GitHub is the most popular one here. Because I've used this, I'm already logged in under this account. It didn't prompt me for the username and password. But if this was the first time you were trying to connect to GitHub, it will ask you for your username and password. Also, if you have two-factor authentication set up in GitHub, it's also going to ask you here. Let's pick the repo. My repository, in this case, is called Bike Shop, and I only have one branch, which is my master branch. I'm going to click on OK, and I see a notification saying it's now successfully set up the deployment source. So if I head back to my deployment options, I now see the my web app is now fetching from my GitHub repo account. So this process is going to take a couple minutes, but while it's doing the fetching and building, we have something else we need to take care of, which is our database. Now, our database is an on-prem database, so I need to migrate that over to my Azure database from my MySQL. And to do that, let me go to my development machine. I'm going to use a tool that's called Database Migration Wizard from the most popular tool for MySQL, and that is MySQL Workbench. And go on to Database tab and click on the Migration Wizard. There are about a dozen steps here that is categorized into 3 buckets. So the first bucket is you need to specify a source and target pair. Let me start my migration here. And in this case, because my source database is my on-prem server, so that is going to be my local host with the IP address 127.0.0.1, and I'll be using my root credential for that. For my target selection, I'm going to use a existing database that I have on Azure Database, and that connection is called CODEMODB. And notice the host name for any Azure database is going to end with .database.azure.com, and your username is also the admin name at the name of your database here. So I'm going to click next, and the wizard is fetching the schema from the source database, and it's asking me which database I would like to migrate over. In this case, the Wordpress web app is using the database called MySQL Database 033. So let me select that and click next, and then a few more validations. In the second category, this is where the migration wizard is going to start creating the schema object on my target database. And it detected on the database that I selected there are about 26 tables. And I'm just going to pick all 26 tables, and no warning here, and nothing interesting here. I'm going to skip. Okay, so at this step, it just imported all the schemas from my local host to Azure Database. And in the results panel, it is telling me the 26 tables that are now created on Azure. The last step is to transfer the actual data over. And to do that, you have a few options. The default option is to transfer everything online, or you can pick to use the offline process by kind of like a MySQL dump approach, by exporting everything to a text file and re-import it. I'm going to leave everything as the online transfer method and click next. And now it's starting to import. My database is fairly small, so it already finished. I'm going to click next. And it looks like everything got imported, and the wizard is giving me a summary of everything that is imported. So it looks good. Let me go to the database and check if everything looks kosher for good measure. So this is the database, MySQL database 033. Expand that. I see a whole bunch of tables here. Good. Okay, so now my database has been migrated over. Let me head back to the web app page and see how the build is doing. Let me go back to my deployment options. And okay, it looks like my initial image is already pulled from GitHub, and the image is already being built. So now at this point, I should be able to go to my the new website on Azure by clicking on this link. So let's see, 3, 2, 1, and Shazam! Here's my database, my shopping cart application has been migrated over from on-prem to Azure, just like that. And before we call it a day, let's kick the tires on this thing, and I'm going to add some stuff onto cart, and just make sure everything works. Now I've added this to cart, and then proceed to checkout, and it's asking me for my payment information. Okay, so looks like everything's working. I do have one more step to finish my migration, though. So what I've done here is, number one, I've deployed the bits to my new web app application on Azure. Number two, I have migrated my database over. However, at this point, my web app is still talking to the old database that is on-premise. So what I need to do is, as a final step, is to update my database connection on my new web app. And to do that, let me head back to my dev box and open up the code in my favorite code editor, VS Code. I've already got the new connection string created in the configuration file, so all I need to do is just uncomment these two lines, both the username and the database host. And let me get rid of the old database connection. Obviously, this is a demo. In a real production situation, you would not put your username and password in a configuration file and put it on GitHub. But so now I've got my changes made. I'm going to commit those changes to GitHub. Updated, give it a command, updated connection string. Oh, I need to add this guy. I screwed up the sequence. Let me just add one more space here, save this. What I forgot to do is I need to add the change to the change set first, and then commit. So now the change is committed, and I'm going to push this to my repo. Okay. So it looks like the changes pushed to GitHub. Now let's head back to my web app. Go back and going back to the deployment options. And what you see here is the latest changes I just committed, updated connection string. So what I've just demonstrated here is the continuous integration between my web app application and the GitHub repo. Pretty cool, huh? All right, let's head back to the slides. So I just want to quickly summarize everything we've done so far. We've created two web apps. One web app using the Django framework with Azure Database for Postgres. Another web app with the Wordpress framework using Azure Database for MySQL. We also migrated an existing shopping cart application from on-prem to Azure. And then last but not least, we showed how easy it is to integrate or to continuously integrate your code into the new web app you have set up in Azure via the integration between GitHub and web app. And we've done all that in less than 30 minutes or so. And I was able to do that because of the power of Azure Web Apps, Azure Database for MySQL and Postgres, and the deep integration between the two. Okay, that is all I have for now. And next up, we're going to have Sunil to talk about some of the database fundamentals. Sunil?
Good morning, folks. My name is Sunil, and I'm the Principal Program Manager and overall lead for the MySQL and PostgreSQL service for Azure. Sean took you through the journey of how to go deploy apps. So now I want to talk about a little bit more on what is this Azure Database for MySQL and PostgreSQL, right? So first, it's a fully managed database service on Azure, and what we have done is we have extended the platform on which we had released Azure Database, our Azure SQL Database, and now extended the same platform to include both MySQL and PostgreSQL. So we are using the community edition. So for MySQL, we are using the Oracle MySQL, but it's a community version, and also for the Postgres, we're using the community version. So whichever apps that you're building on-prem or anywhere else that uses the community version, you can bring the same database over, and it is guaranteed to work without any issues. So what you have with this Azure Database for MySQL and Postgres is ability to provision in minutes, that which Sean demonstrated, and it's got the built-in high availability. That means you don't have to necessarily set up replicas and manage those replicas to maintain high availability. And in a moment, I'll also show you how the built-in high availability actually works. And then you have simple scaling. That means as your app becomes viral and highly successful and you need more resources, you can dynamically scale on the fly with minimal application downtime. And similarly, say on the weekends, you're not seeing any traffic, you can dynamically scale it down as well. So it offers you both simple scaling up or down. And also, we are happy to announce the private preview for scale out for the MySQL service. So now we have readable replicas that you can participate with us to join the private preview and use that to scale out your workloads as well. And then we have security out of the box. That means all the data on the disk, including the backups, is encrypted on storage by default, and we do not have options for you to disable it. So it's always encrypted on disk. And also, we have client connections coming to the database by default enabled with SSL. And optionally, there are some open source apps that do not work very well with SSL, and therefore we also allow optionally to disable it. But that's not necessarily our preferred recommendation, but we provided that option to disable just to reduce the friction for bringing those apps that today do not completely support SSL. And then, of course, automatic backups with the ability to point-in-time restore to any time up to 35 days, and also with a recovery point objective of less than 5 minutes. So this gives you peace of mind in case things are going to go wrong, you are able to recover, and also the backups that we take are geo-redundantly stored in another region. So in case there is going to be a disaster and there's going to be a region outage, we can restore that from a geo-redundant copy that's stored in another region. And all these capabilities, like I said, since we use the community edition of MySQL, it is guaranteed to work with any of the existing tools that you use, like Workbench or pgadmin or whatever also the third-party tools, and also continue to use your same existing apps, whether it be a PHP app, a Node.js app, Ruby app. Any apps and open source drivers will work seamlessly against both these databases. So let me now illustrate a little bit about what goes on and what do we mean by built-in high availability. So now here you see that we have a database that is created in US West region, and you have an application, the green box on the right. And there also you see a small rectangle box in blue color called the gateway. So when the application is trying to connect to the database, the gateway is listening on the MySQL or the PostgreSQL port. For the port, MySQL is 3306 and the Postgres is 5432. So application tries to connect through the gateway. The gateway determines where your resource or where your database is in the cluster, and then connects you to your database. Now let's say, for example, this database were to go down. What happens is that we rapidly provision another instance, and since we are not running these databases in a virtual machine, our service is built using the Azure Service Fabric and containers, like a container process. We are able to rapidly create this new container and then have the gateway redirect to the new instance as soon as that's made available. So this does require the client application to have the logic to retry connections for the brief period of time, and typically it's measured in tens of seconds, and your application will be able to work seamlessly and connect transparently to the newly spawned instance in the cluster. And all of this, like as I said, this takes tens of seconds, virtually no application downtime, no need to set up new replicas, and also you're able to save costs as a result of that. So similarly, the scale on the fly, or scaling up or down, works very, very similarly. So you have your application that talks to the gateway which listens to the MySQL or the PostgreSQL port, connects to your database. Now, let's say your website has become virally successful, you want to scale up resources. So when you scale up the resources, you create a new instance, and this is not on the critical path. So while this is happening, your application is still connecting to the old one. And now once the new server is created in the cluster, we detach the storage from the old one, attach this remote storage to the new one, and the application tries to connect, and you're connected to your database. All happens in tens of seconds. And that's what we mean by minimal downtime, and you can configure and scale compute and also storage independently. And as I said, we have security built in, providing native user authentication, which is you can continue to use the same MySQL or Postgres user roles and manage your privileges. Then you have also access controls through SSL, which I talked about, and then define also the client IP firewall rules that you can whitelist so that only certain IPs can talk to the database. And then also with built-in encryption for both the data and the backups, you have your entire database secured by default out of the box. And I talked about the choice of the tools, so I'm going to skip this. So no matter, like whichever packaged applications that you're using or is your favorite, whether it is WordPress, Drupal, Magento, Django, and whichever programming languages that you build your applications with, be it PHP, Node, Python, Java, C#, all of these applications will seamlessly work with the service by just changing your application, by just changing the connection string on your application. Lastly, I also want to leave you with some information about the partnership that we have with Affinity that helps you use this tool at no additional cost to migrate your data from anywhere to the Azure Database for MySQL or PostgreSQL. It's available for you free of cost. It's agentless. That means you don't have to run any additional software on the source or the destination. It uses a change data capture technology to transparently and continuously migrate your data from anywhere to the Azure Database for MySQL and PostgreSQL like it's a continuous application, which means that you do not have any downtime as well. And to get more information, aka.ms/Affinity replicate. So finally, here is what I'll leave you with some resources that you can use to go and access our GitHub account where you can download samples, or you can engage with us on MSDN or Stack Overflow, and also on our Twitter handles if you have any questions. Today, as of now, we are available in about 13 regions across US, Europe, Asia, Japan, and India, and we are continuously expanding to more regions and plan to be available in all Azure Public Cloud regions by our general availability timeframe, which is scheduled before the end of this calendar year. So with that, thank you, and I'll open up for questions. So if people have questions, if you can please come forward to the mic, and so that everybody on the phone or everybody that is streaming in can listen in as well. Thank you.
Yeah, I just wanted to, you mentioned earlier that there's a public preview starting up, and I just want to specifically know, is it a public preview for MySQL or PostgreSQL for database for Azure, or are they both going to be in public preview?
They are both, so currently both MySQL and PostgreSQL service are in public preview. We have been in public preview since May of this year.
Okay. So is that that's the public preview that you were referring to? There's not
Yes.
like a new one? Okay.
That is correct.
No, I think he was referring to the public preview of scale out scenario. You were
So if your question was specifically related to the readable replica, then that is currently in private preview. So we are inviting nominations from customers who want to try out the read replica in private preview. Yes.
Thank you. Currently in our company, we are POC migrating from Oracle databases that we have to EDB. That's a POC project that we're running. So now that PostgreSQL is available as a PaaS offering, do you think it's feasible that we could migrate from Oracle databases to PostgreSQL?
Very good question. So to give you the true answer, yes, you can migrate from Oracle to the PostgreSQL service. We now, like as I said, have a Attenuity Replicate tool that supports migrating from Oracle to PostgreSQL. So the answer from the data part is yes, but typically most of the effort on the migration from Oracle to Postgres is in the application. So if the application is sorted out and you have a path to move from Oracle to Postgres, then we have the tools and we have everything that the community Postgres has to actually make that successful. Any other questions?
I have a question regarding the cost projection. If you have those dynamically kind of scale up and scale down, how can you proactively control your cost? I mean, is it? I mean, I know there's kind of a pricing model, but is that you're actually basically being charged for the data storage, or is it more than that?
So our pricing model is based on the amount of compute resources you provision and amount of storage you have. You can scale each of them independent of each other, and you're billed for compute and storage. So when you provision your instance, for example, when you create an instance with standard tier with 100 compute units, it comes included with 125 gigabyte of storage. So you don't pay for the 125 gigabyte of storage. But say, for example, then you want your storage needs increases and you want to increase to 250 gigabytes. So you will be paying for the additional 125 gigabytes on top. Right? So, but to answer your first question and as to whether there is a way and you can cap your spending, we don't have that capability where you can put a dollar number and then say, okay, I want to manage my resources within this dollars. However, having said that, what you can do is we have metrics and alerting on those metrics that you can use to tell, like for example, if the CPU percent is getting below, say, 20%, you can write a script that scales down the resources from, say, 200 to 100. And then if the CPU percent is like 60% or greater than 60%, then you can do an automatic scale up. So just to answer your question, we don't have a capability to box it based on a dollar number, but we have ways in which you can, based on the CPU percent utilized, you can control how you want to go up or down. Any other questions?
Do you get more I/O with buying more storage?
That is correct. So the I/O scale with the storage at 3 IOPS per gigabyte. So by default, when we provision standard with 125 gigabytes, you get 375 IOPS. And when you increase, if you want more IOPS, you can add more. You have to add more storage, and it'll scale linearly at 3 IOPS per gigabyte. Any other questions? Thank you so much. I know it was very early in the morning, so appreciate you all coming in. Thank you.